Thank you. So thank you to the conference organizers for inviting me to share some of this work with you. It's part really of a much larger and more ambitious research program where Yvonne and I are basically trying to take tools that have been successfully applied in the market design literature and trying to use them to answer bigger picture questions in economics. So in this paper, we try to tackle the meaning of property in an economic model. And we find some interesting connections with the top trading cycles algorithm in particular. So that's what this paper is about. And we have ongoing work that tries to extend this to a larger class of models. And I'll talk a little bit about that as well. Okay, so the starting point for this paper is really the observation that in the real world, property is pretty complicated. So, there's things like joint and collective ownership. And in many circumstances, property rights are implicit or they're qualified in some sense, right? So for example, suppose you own a condo, you might not be able to sell that house unless, all the other people in your building agree. Right. So there are all these qualifications as to how people can trade and use property. And so we try to answer the question, how can we accommodate this complexity when studying exchange and allocation problems? Now, when you think about complex property arrangements, you quickly run into the observation that classic solutions, such as the core specifically, perform poorly when things are non-standard. So the core, for instance, is often empty. And I'll show you some easy examples of where that happens. And in many applications where the rhetoric of property is invoked, it's actually hard to apply some of these solutions. So for example, in student and school matching, we might often talk about students trading priorities to schools. But it's not clear how you would actually take that idea and apply it to a core-like solution. Okay, so in this paper, what we do is we provide a reinterpretation of endowments in an exchange economy as a distribution of the right to exclude, rather than as bundles of things to trade. So it's really trying to take a different perspective as to what it means to have things in an economic model. Now, focusing on exclusion rights is not our idea. Okay, so the idea of exclusion as a fundamental characteristic of property is really something that's central in the way the law understands property. So, for example, on the screen there, I put up a quote that you would see if you opened up a typical property law textbook in the United States, right? It's like this important thing, this idea that people can exclude others from things they own. And what we do is we take that insight of exclusion rights and we use it to develop a new solution concept that we can apply to exchange economies specifically, which we call the Exclusion Core. And one thing this framework allows us to do, it lets us analyze many types of complex problems using a unified toolkit. So we can talk about private and joint and public ownership, things such as explicit and implicit rights, and even qualifications to property rights using one type of solution. Okay, so the paper has two parts. The first part introduces something that we call a simple economy. And this is what I'll talk about today in my exposition of this research. And basically, it's just a reinterpretation or a generalization of the classic house exchange economy from Shapley and Scarf back from the 70s. Okay, and we use this as a really good sandbox in order to develop our solution. The rest of the paper, the second half of the paper, builds upon the first half, but it introduces this idea of priorities. Now, priorities are a well-known construct in the market design literature, right? So if we think about assigning students to schools, there are usually priorities to those seats. We offer a reinterpretation of what priorities mean in an exchange economy, and we use them basically to describe relationships among people and the goods in the economy. And we then explain how you can use that idea to endogenously derive endowments, which we interpret as exclusion rights, and then apply our solutions. So I will not have time to talk about this part of the paper today, but it's in some way the technical essence of much of our analysis. I should also point out that we divided this paper into two parts. They also have interesting connections to literatures outside of economics. So we only discovered this later when we started talking about our theories with, for example, property law experts. And so one thing we learned is that the simple economies that we develop, they basically try to model property in an in rem perspective. So these are, I guess, legal jargon, while relational economies model property in an in personam perspective. And basically, these just are conceptual paradigms that lawyers have in thinking about property. So we think it's interesting that these two frameworks actually help us accommodate those lines of thinking. It helps us formalize those approaches. So let me go on and just introduce what a simple economy is. So this is essentially a generalization of the classic house exchange economy from Shapley and Scarf. Okay, so there are basically four ingredients. The first is a finite set of agents. We're also going to have a finite set of goods in our model. We're going to call our goods houses just to conform to tradition. And each of these houses are discrete. So these are discrete goods, they cannot be shared, and there is no money in the model. We also allow for an outside option, which we just call the null house. Agents, of course, will have preferences over the set of houses, and each agent wants only one house at most, okay, and houses cannot be shared. Finally, we introduce this idea of endowments, which we will model as a function that will describe what each coalition owns. Okay, so let me tell you a little bit more about what this function's properties are. Okay, so as an economy's endowment system is going to just assign to each set of agents a set of houses that they own. And it satisfies four natural properties. The first three are fairly uncontroversial. Okay, so the empty set owns nothing, a coalition owns anything that a sub-coalition owns, and the grand coalition owns everything in the economy. And then the fourth assumption is in some way the technical one that lets us get some results. It's basically saying that each house, there's some critical set of owners that a coalition owns a house if and only if that coalition is a subset of the larger group. Okay, so lots of classic cases satisfy these assumptions. So the Shapley and Scarf model, of course, does. In that case, each agent owns a single house. The Hilland and Zeckhauser model also satisfies this set of assumptions. Here, everything is public property. So the grand coalition owns everything, but no sub-coalition actually has anything. The model of house allocation with existing tenants, of course, is a special case of this model, as are various models involving kidney exchange, et cetera. Okay, so it covers a broad set of cases. An allocation, of course, will just assign agents to houses, and houses cannot be shared, and each house has at most one occupant. Okay. So let me just review some basic definitions that will help me introduce our definitions later on. And these are the weak and the strong cores. So these are very classic solutions applied to this class of problems, of course. They form the bedrock of much of analysis in these discrete exchange economies. Okay, so we can say that a coalition can strongly block an allocation if there is an alternative allocation that everybody in the coalition strictly prefers and involves the coalition reallocating goods within their endowment. Okay. And the set of allocations that cannot be strongly blocked in this way defines the economy's weak core. Now, this is closely related to the economy's strong core, which has a very similar definition. Okay, the only difference is that now, when a coalition decides to block an allocation, not everybody in the coalition needs to be better off. Only one person needs to be strictly better off. Others can be indifferent. Okay, and the strong core is the set of allocations that cannot be weakly blocked by any coalition. Now, these two solution concepts, right, they're very classic ones, and they perform quite well in many benchmark cases, right? So in the Shapley and Scarf model, where each agent owns one house, they do perfectly fine. Okay, so there are many weak core allocations. There's a unique strong core allocation, of course, and it's the one that's identified by the trading cycles algorithm. And it has some very nice connections also to competitive equilibrium. Okay, so in this economy, definitely the strong core solution is the right kind of outcome that you would expect to arise. But it's quite easy to construct economies where neither solution really gives you the intuitive outcome that you would expect. So here is one simple example. We call it the kingdom. Okay, so suppose there are 3 agents and only 2 houses. Okay, but one agent, let's call him the king, happens to own both of them. Okay, the other 2 agents, the peasants, have nothing. And the agent's preferences are fairly straightforward. The king wants house 1, the other 2 agents prefer house 2. So if you think intuitively as to the kinds of allocations that you would expect to arise in this economy, the most natural one would be that the king gets house 1, his favorite choice, and then house 2, the other one, is occupied by one of the other agents. Okay, who in particular, I don't know, everything is symmetric, but you expect both houses to be occupied by someone, and house 1 should go to the king. It's actually a little bit disappointing that neither the weak core nor the strong core really converge on this outcome. Okay, so the strong core in this economy is actually empty. The king always gets house 1, but then house 2 just keeps getting reallocated in a cyclic fashion. The weak core, on the other hand, contains some unintuitive outcomes. Specifically, the weak core doesn't guarantee Pareto efficient outcomes in this situation. So the king might take house 1, but house 2 would be empty. And that just seems implausible to us. Okay, so we tried to fiddle around with the definition of blocking to see, well, can we use this idea of exclusion rights to develop a better solution that might let us pin down the intuitive outcomes in that case. Okay, so here is our first stab at the problem. We'll say that a coalition can directly exclusion block an allocation mu with an alternative if everybody in the coalition is better off at the alternative, and this is the crucial innovation, if there is some agent in the economy who is harmed by that reallocation, then what must be true is that that agent was initially assigned to something that was owned by the coalition. Okay, so essentially owning something lets you, it's a license to harm others by excluding them from that good. And we define the direct exclusion core as the set of allocations that cannot be directly exclusion blocked by any coalition. Okay. Now this solution here has some nice properties. Okay, so it's actually stronger than the weak core. It's going to be non-empty in the class of models that we study. And actually in the kingdom example, it picks out the two intuitive outcomes that I briefly highlighted. Okay. But once you start thinking about exclusion rights, one thing that becomes apparent is that agents are not necessarily limited to exercising their exclusion rights to goods that they own. Okay, so you could actually imagine very complicated relationships arising where agents try to exploit the pattern of trade to essentially magnify their power in an economy. Okay, so here is a motivating example. Suppose there are 6 agents and each agent owns exactly 1 house. Okay, here I've listed the preferences of the agents. Okay, and there are 2 interesting allocations here. Okay, in allocation mu, just to explain how these diagrams are read, each agent is pointing to the house that he is assigned to, and each house is pointing to its owner. Okay. Now, I would argue that allocation sigma is a more robust outcome in this economy. Okay, so let me explain why. In allocation mu, there are 2 agents that would like to reallocate houses. Okay, agents 1 and 3. Now, in principle, house 3 could be taken by these agents as a coalition because, well, agent 3 owns it, so we can exclude agent 6 from it. House 2, on the other hand, which is something agent 3 wants, is not in the coalition's endowment. Okay, but the coalition might be able to use its exclusion power to gain access to this house. Okay, and this is how they would do it. Okay, the coalition could say to, for example, agent 2 in this case, the following. Agent 2, you are assigned house 1 at this allocation. It's your favorite house. It's in your interests to exclude agent 4 from house 2 and give us access to it because otherwise we can harm you. Okay, so this pattern of trade basically introduces these interdependencies that magnify agents' power. Okay, so there's a fundamental fragility at allocation mu. This fragility is absent at allocation sigma. Okay, so here again, there's a coalition of agents that would like to reallocate houses, but that group in the center, right, the pattern of trade insulates them from any threats of exclusion or reclamation that the others would want. Okay, so we use this idea of these chains basically to define the coalition's extended endowment as follows, right? We take a coalition and then we look at all the things that are owned by the coalition, look at the agents assigned to those things. That increases the set size, and we just iterate this process again and again and again. And eventually we define something known as the extended endowment, okay, capital omega. And we use this idea to just define the exclusion core, which is our main contribution, right? So we'll say that a coalition can indirectly exclusion block if everybody is better off, and if anyone is harmed, they were excluded from something in the coalition's extended endowment. So let me just briefly list 2 sets of results and I'll wrap up. Okay, so under our assumptions, the exclusion core is going to be non-empty. It's independent of the strong core, but it aligns with the strong core in many key cases. In one class of economies that you might be familiar with, the house allocation problem with existing tenants, The exclusion core actually is a recharacterization of the you request my house, I get your turn algorithm. So it actually has a very tight connection with trading cycles, which we found to be surprising. So given that I'm out of time, let me just conclude by identifying some related literature, and I'm happy to take questions.